Before we talk about services, architectures, or even security, we need to understand where AWS actually runs. And that's exactly what this lesson is about. In this video, we're going to break down the AWS Global Infrastructure, one of the most important foundations of the AWS Cloud and a core topic on the exam. We'll start by clearly defining what AWS regions, availability zones, and edge locations really are, and how they relate to each other. You'll see why availability zones are designed to be isolated, why they don't share single points of failure, and how that design helps you build highly available and resilient applications. We'll also talk about high availability and how AWS expects you to achieve it, especially by using multiple availability zones within a region. This is a concept that appears constantly in exam questions, and understanding it conceptually makes those questions much easier. Then we'll zoom out and look at multiple regions. When should you stay in one region, and when does it make sense to deploy across regions? We'll connect this to real-world use cases like disaster recovery, business continuity, data sovereignty, and low latency for global users. Finally, we'll cover edge locations, what they are, why they exist, and the benefits they provide when delivering content closer to end users around the world. By the end of this lesson, you won't just memorize definitions, you'll understand how AWS infrastructure is designed, why it's designed that way, and how to reason through exam questions with confidence. Let's start by building a clear mental picture of how AWS is structured globally. Let's start with the biggest building block of the AWS Global Infrastructure, AWS Regions. An AWS region is a physical geographic location in the world where AWS has built multiple data centers. When you choose a region, you are choosing where your workloads physically live. This decision affects performance, availability, cost, and compliance. One of the most important characteristics of AWS regions is isolation. Each region is designed to operate independently from every other region. That means a major outage, natural disaster, or network issue in one region does not automatically impact another region. This isolation is what enables strong fault tolerance and global disaster recovery strategies. Every region is also fully independent in terms of services. Each region has its own compute, storage, database, and networking infrastructure. When you create an EC2 instance, an S3 bucket, or a database, it exists inside a specific region. AWS does not share these resources across regions. Another key reason regions exist is data sovereignty and compliance. Many countries and industries have laws that require data to stay within certain geographic boundaries. By choosing a specific region, such as EU West 1 for Ireland or AP Southeast 2 for Australia, you can meet local regulatory and residency requirements. Importantly, AWS will never move your data outside a region unless you explicitly configure it to do so. Regions are identified using a standardized naming system. For example, US East 1 represents Northern Virginia. EU West 1 represents Ireland. AP Southeast 2 represents Sydney. The name itself tells you both the general geography and the specific region identifier. From a design and best practice perspective, using multiple regions can significantly improve resilience and disaster recovery. For mission-critical workloads, organizations often deploy primary systems in one region and backups or failover environments in another. If an entire region becomes unavailable, the application can continue running elsewhere. However, it's also important to remember that multi-region architectures add complexity and cost, so they are typically used when there's a clear business requirement, such as global users, regulatory needs, or strict uptime requirements. To summarize, regions are physical, geographic locations. They are isolated and independent. They support compliance, fault isolation, and performance optimization. And they form the foundation for everything else in the AWS Global Infrastructure. Once you understand regions clearly, it becomes much easier to understand how availability zones and edge locations fit into the bigger picture, which we'll explore next. Let's now zoom in one level deeper inside a region and talk about availability zones, often called AZs. An availability zone is an isolated location within an AWS region. Each AZ is made up of one or more discrete data centers, and these data centers have their own independent power, cooling, and networking. This independence is intentional. It's what allows AWS to protect your applications from localized failures. One of the most important ideas to understand is fault isolation. If something goes wrong in one availability zone, such as a power failure or networking issue, it does not impact the other AZs in the same region. This means your application can keep running as long as it's deployed across more than one AZ. At the same time, AZs are designed to be close enough to each other to support very low latency communication. AWS connects AZs using high-speed, private fiber networking, which allows for things like synchronous data replication between AZs. This is why services such as Amazon RDS or load-balanced EC2 applications can safely span multiple AZs without noticeable performance impact. This design enables high availability, which is a core AWS best practice. AWS strongly recommends deploying applications across at least 2 availability zones. For example, EC2, instances behind a load balancer in multiple AZs. Databases with multi-AZ replication. Applications that automatically fail over if one AZ becomes unavailable. Most AWS regions contain at least 2 availability zones, and many regions offer 3 or more. This gives you flexibility to design resilient architectures without needing to leave the region. In practice, when you launch resources, such as an EC2 instance, an RDS database, or other services, you often choose the availability zone. By spreading those resources across AZs, you dramatically reduce the risk of downtime caused by a single point of failure. To summarize, availability zones are isolated locations inside a region. They do not share single points of failure. They are connected by low-latency, high-speed networks. And they are the primary mechanism AWS provides for high availability within a region. Understanding AZs is critical, because most AWS exam questions about availability and resilience are really testing whether you know when and how to use multiple availability zones. Now let's talk about edge locations, which play a very important role in performance and user experience. Edge locations are globally distributed AWS sites designed to deliver content and network traffic as close to end users as possible. Unlike regions or availability zones, edge locations are not where you run your core applications. Instead, they focus on speed, caching, and traffic optimization. The most common service that uses edge locations is Amazon CloudFront, AWS's Content Delivery Network, or CDN. When you use CloudFront, copies of your content, such as images, videos, static websites, or APIs, are cached at edge locations around the world. When a user makes a request, the content is served from the nearest edge location, not from the original region. This dramatically reduces latency, improves load times, and creates a better experience for users, especially those located far from your primary AWS region. Edge locations are also used by other services, such as Amazon Route 53, AWS WAF, and AWS Global Accelerator. These services benefit from being close to users by improving DNS resolution speed, blocking malicious traffic earlier, and accelerating global application access. It's important to understand the hierarchy here. A region is a large geographic area that contains multiple availability zones. An availability zone is one or more data centers inside a region, designed for high availability and fault isolation. An edge location is a global site focused on content delivery and network acceleration, not application hosting. In summary, edge locations help AWS customers build applications that are not only resilient and scalable, but also fast and responsive for users anywhere in the world. This is especially important for global applications, media delivery, and low-latency APIs, and it's a concept that appears frequently on the Cloud Practitioner exam. Now let's talk about high availability, one of the most important concepts in AWS architecture, and a key topic for the Cloud Practitioner exam. High availability means designing systems that stay up and accessible, even when something goes wrong. In real life, hardware fails, networks break, and data centers can go offline. AWS assumes failure will happen, so the goal is to design in a way that minimizes downtime and keeps services running for users. At a basic level, high availability is about uptime. You'll often hear uptime measured in nines, like 99.9% or 99.99%. The more nines you need, the more carefully your architecture must be designed. Downtime is the opposite, periods when users can't access your system. And AWS architectures aim to keep that as close to zero as possible. A core concept behind high availability is redundancy. Instead of relying on a single component, you duplicate critical resources so that if one fails, another can immediately take over. This leads us to fault tolerance, which is the ability of a system to continue operating even when parts of it fail. In AWS, the primary way to achieve high availability is by using multiple availability zones. Availability zones are isolated from each other, with independent power, cooling, and networking. When you deploy your application across two or more OSes, a failure in one OS does not take down your entire system. For example, you might run application servers in two OSes behind a load balancer. If one AS becomes unavailable, traffic is automatically routed to the healthy OS. From the user's perspective, the application continues to work. Many AWS services have high availability built in. Amazon RDS, when configured for multi-OS, automatically replicates data to a standby instance in another OS and performs automatic failover. Amazon S3 stores data redundantly across multiple OSes and is designed for extremely high durability. Amazon DynamoDB automatically replicates data across OSes without requiring manual configuration. Another key service for high availability is elastic load balancing. Load balancers distribute incoming traffic across multiple instances and OSes, and they only send traffic to healthy resources. If an instance or an OS fails, the load balancer simply stops using it. Autoscaling also plays an important role. Autoscaling replaces unhealthy instances automatically and adjusts capacity based on demand. This helps maintain availability not only during failures, but also during traffic spikes. A good high availability mindset follows one simple rule: design for failure. Assume every component can fail and architect your system so that failure does not cause an outage. Avoid single points of failure. Distribute workloads across OSes, monitor your systems, and regularly test failover behavior. In AWS, high availability is not something you bolt on later, it's something you design from the beginning. By using multiple availability zones, load balancing, auto-scaling, and managed services, you can build systems that are resilient, reliable, and always available to users. Now that we understand how AWS regions and availability zones work, let's talk about using multiple AWS regions, also known as a multi-region strategy. This is an important concept for the AWS Cloud Practitioner exam because it explains how organizations design for large-scale resilience, global performance, and compliance. First, let's set the foundation. An AWS region is completely independent from every other region. That means different power, networking, infrastructure, and physical locations. So while multiple availability zones protect you from local failures, multiple regions protect you from regional-level failures. Think of it this way. AWSs protect you from a data center failure. Regions protect you from a geographic failure. Why do organizations use multiple regions? There are three main drivers you need to remember for the exam: disaster recovery and business continuity, compliance, governance, and data sovereignty, and latency reduction and global performance. 1. Disaster recovery and business continuity. One of the most common reasons to use multiple regions is disaster recovery. If an entire region becomes unavailable due to natural disasters, large-scale power outages, major network failures, a second region can take over. AWS supports this with services like Amazon Route 53, which can monitor the health of your application, automatically route traffic to a backup region when the primary one fails. You'll often see exam questions mention RPO and RTO. RPO, Recovery Point Objective. Think how much data you can afford to lose. RTO, Recovery Time Objective. Think how quickly you need to recover. Multi-region architectures allow much lower RPO and RTO than single-region designs. 2. Compliance, governance, and data sovereignty. Another major driver is regulatory and legal requirements. Some countries require that customer data stays within national borders. Data is processed only in specific geographic locations. AWS regions help organizations meet these requirements by letting them choose where data is stored, isolate workloads for compliance audits. For example, EU workloads may run in EU Central 1, Frankfurt. Australian workloads may run in App Southeast 2, Sydney. This is known as data sovereignty, and it's a key exam keyword. 3. Latency reduction and global performance. Using multiple regions can also dramatically improve performance for global users. Instead of serving all users from one location, organizations deploy applications closer to customers around the world. AWS supports this through active deployments in multiple regions, Amazon Route 53 geolocation or latency-based routing, AWS Global Accelerator, which optimizes network paths globally. The result: faster response times, better user experience, more resilient global applications. Common multi-region architecture patterns. Not all multi-region designs are the same. AWS defines several common strategies, and you should recognize them conceptually for the exam. Backup and restore. Data is backed up in one region, restored in another only during disaster. Lowest cost, but slowest recovery. Pilot light. Critical components run in a minimal state in the secondary region, scaled up during a failure, faster than backup and restore. Warm standby. A smaller version of the full environment is always running. Faster failover, higher cost. Active/active, multi-site. Full production environments run in multiple regions at the same time. lowest RTO and RPO, most complex and expensive. For the Cloud Practitioner exam, you don't need to design these, you just need to recognize when and why they're used. Using multiple AWS regions allows organizations to survive large-scale failures, meet strict compliance requirements, deliver low-latency global experiences. It's a strategic decision that balances resilience, performance, compliance, and cost. And on the exam, whenever you see disaster recovery across geographies, data residency laws, global users with low latency needs, think multi-region architecture.
Thank you for watching. See you in the next class.